Hello, my name is Karthike Kumar, and today I'm here to discuss about Tourgether360, collaborative exploration of 360 tour videos using pseudo spatial navigation. This is a work that I did with my amazing collaborators, Lev Puretsky, Jianan Lee, and Professor Tony Tang from the University of Toronto. 360 videos have become increasingly popular in the last few years, mostly because they provide a rich sense of presence where the user can pan around to look in various directions. On a desktop, this is achieved through a drag and drop interface, and on mobile and VR, a gyroscopic interface is used to control the direction of the viewpoint. 360 tour videos are characterized by a non-fixed camera moving along a path in a scene. In addition to travel and tourism, 360 videos are used by realtors to share potential properties, or in education, where instructors can share virtual trips to historical sites, as well as in architecture, where 360 videos are used to view simulated environments before they are even constructed. However, one challenge is that most 360 video players are intended for a single viewer. In this project, we explored the question, how do we design a collaborative 360 video player that allows multiple people to communicate and interact with one another in a 360 video seamlessly? By looking at prior research in this area, we identified three main challenges to collaborative 360 video navigation. Temporal awareness of the collaborator, where it can be challenging for users to know where the other user are in the video temporarily. Secondly, specific to 360 videos where users can pan around to choose their own perspective, it can be challenging for users to maintain an awareness of where other people are looking in the video. And lastly, current 360 video players do not provide a method to point and refer to specific objects in the video environment. Hence, deictic references can be difficult. To address these, we designed a system called Tourgether360. As you can see here, we imagine 360 video as a shared 3D space that users can inhabit instead of just passively observe. This is designed to allow multiple collaborators to view a 360 video in a way that allows them the freedom to explore the environment on their own, but also maintain an awareness of their collaborators and what they are looking. We based the design of Tourgether of the following four design goals. First, providing awareness of collaborators, facilitating semantic navigation of the video, smooth engagement with other users' perspectives, and enabling deictic references. First, Tourgether 360 aims to provide an awareness of others in the video space. We do this by translating the 360 video into a 3D space where the timeline is projected as a blue path in the environment. For instance, in this clip, on the left is the first-person view of a user, and on the right is the avatar of that user as seen by other users. These avatars move on the blue path below, which not only represents their spatial position, but also their position in the timeline of the video. For example, here, the other user who appears around the corner ahead is a few seconds ahead in the video as well. So if we decide to pause the video while the other user continues to watch, they'll just move along the path. Next, enabling users to semantically navigate the video by leveraging their spatial awareness of the 360 environment. In addition to a timeline, Tourgether has a minimap which shows 2D overhead view of the video scene. Users can click on the minimap to open the global view of the whole environment and can drag on the map to navigate to specific locations in the video environment. Next, supporting collaboration through seamless engagement to other users' perspectives. Tourgether allows users to sync up their viewports by double-clicking on the other user's avatars. Clicking on the other user's reticle on the minimap can also be used to synchronize their viewpoints. And lastly, supporting deictic references. Users can place markers in the video space by double-clicking on stationary objects. These markers stick to the place they were attached to, irrespective of the motion of the camera. These markers are hidden when they are occluded by another object, such as a wall or a building. In terms of implementation, the path of the camera was reconstructed through an open source implementation of simultaneous localization and mapping, which was run on a 360 video on a per frame basis. This data was then sampled at 0. 0.5 seconds to get the avatar's path in the video. An invisible 3D model of the environment was extracted through Google Maps and was overlaid on top of the video by manually scaling and rotating the model to the proportions visible in the video. This model was later used to implement features like the minimap and the dynamic exclusion of markers, avatars, the path, etc. To evaluate our system, we conducted two user studies. The first study was focused on determining the utility of the minimap and the embodiment in specific well-defined collaborative tasks as compared to a baseline interface. Please refer to the paper for more details on this study. In this presentation, I'll only be discussing about the second study, which was more concerned about users' qualitative experience with Tourgether. This was on mostly open-ended type collaborative tasks. We conducted the second study with 8 pairs of participants over Zoom and Skype, in which participants completed tightly and loosely collaborative tasks such as finding the entrance of a building or agreeing on a point to take a photograph together from. We used videos of 3 popular tourist locations for these tasks. The user response to Tourgether was mostly positive, with most participants agreeing that it was an easy, exciting, interesting, and an inventive experience. One interesting thing to come out of the study was how users perceived Tourgether. Users often perceived it as a social experience. Since the participants saw each other as avatars, they referred to objects in the scene in relation to each other's avatars. Users relied on the embodiments to tell whether their partners were with them or just nearby, and adjusted their speech and conversation accordingly, where they would call each other in different ways. For example, they'll say, come over here when they are distant, versus look at this when they were nearby. Participants also compared this to a video game, as in addition to watching the video, they could also simultaneously interact with the system as well. We also found that people used spatial navigation more so than temporal ones when trying to refer to one another to other areas of the map or parts of the video. This is interesting because by default, videos are based on time. Finally, what implications does Tourgether have over future work on collaborative video players? Through semantic metaphors like minimap and avatars, Tourgether brought out interesting behaviors like deictic references and a sense of embodiment in an otherwise video watching experience. Future work could explore what other kinds of semantic metaphors are important to effectively navigate these videos. Secondly, Tourgether visualizes 360 videos as a shared 3D space where users can explore and interact with the content and among themselves. This leads to a notion of cohabiting a place together, rather than just watching together. It would be interesting to consider what other kinds of media we can design immersive experiences for, where people feel as if they are together. I'll end here with the message of our talk that Tourgether360 is a prototype that supports collaborative exploration of 360 tool videos by embodying collaborators in a 3D virtual scene. This allows people to navigate the videos spatially. We refer you to the paper for further details. Please get in touch if you have any additional questions. I would also like to thank MyTax and NSERC for funding a part of the project. Thank you for joining me today.